For years, the Toyota Tundra built its identity around one core idea: reliability so consistent you never had to question it. Owners expected to push these trucks hard, towing, hauling, piling on miles, without worrying about what was happening under the hood. That expectation is exactly why the situation with the 2022-2024 Tundra hit so differently. This wasn't a minor inconvenience or a routine recall. It wasn't about electronics or comfort features. It was something far more serious: widespread engine failures. Reports started surfacing of engines knocking, losing power, and in some cases shutting down entirely while driving. For any automaker, that's a major issue. For Toyota, a brand built on dependability, it quickly became something bigger: a reputational crisis. After months of mounting complaints, investigations, and pressure from owners, Toyota announced it had identified the issue and implemented a fix. But the full story is more nuanced, and the implications go beyond a simple problem solved. At the center of the issue was something deceptively small: machining debris. The affected trucks used Toyota's newer 3.4-liter twin-turbo V6, known as the I-Force engine. On paper, it represented a major evolution: more power, improved efficiency, and a shift away from the older V8 design. But during manufacturing at Toyota's Alabama facility, microscopic metal particles from machining processes were not completely removed from some engines. Those tiny fragments turned out to be a massive problem. Circulating through the oil system, the debris would lodge itself in critical engine components, especially the crankshaft's main bearings. Once embedded, the damage process began quietly but inevitably. Inside the engine, the sequence is brutal. Contaminants disrupt oil flow, friction rises sharply, bearing surfaces degrade, and wear accelerates. What might begin as a faint knocking noise is already a sign that internal damage is underway. Left unchecked, it leads to complete engine failure or seizure. What made this issue especially concerning wasn't just the failure itself, it was how quickly it could escalate. Drivers reported sudden loss of power at highway speeds, engines stalling without warning, and loud knocking noises followed by total shutdown. In a full-size truck often used for towing or long-distance travel, that's not just inconvenient, it's dangerous. The scope added another layer of concern. The initial recall affected over 100,000 vehicles, but by late 2025, Toyota expanded it, significantly adding roughly 127,000 more units. This expansion even included related luxury models like the Lexus GX and Lexus LX, raising questions about whether the issue was purely manufacturing-related or something deeper. Toyota's response was decisive and expensive. Rather than attempt partial fixes, the company opted to replace entire engines in affected non-hybrid Tundra models at no cost to owners. This wasn't a small-scale repair campaign, it involved replacing well over 100,000 engines. From an engineering standpoint, this approach makes sense. A full engine replacement eliminates any chance that hidden debris remains in oil, passages, or critical components. It restores long-term reliability in a way that piecemeal repairs simply can't guarantee. But the situation becomes more complicated when you look at hybrid models. Hybrid versions of the Tundra were initially excluded from the full engine replacement program. The reasoning was tied to their built-in fail-safe. If the gasoline engine fails, the electric motor can temporarily keep the vehicle moving, allowing drivers to get to safety. While that reduces immediate risk, it doesn't address the underlying mechanical issue. The engine itself is still vulnerable, which raises concerns about long-term durability, resale value, and overall confidence in the vehicle. Meanwhile, Toyota didn't just focus on fixing existing trucks, it also updated its production process. Starting around April 2024, new engines were built with improved cleaning procedures to better remove machining debris. The company also introduced stronger bearing materials designed to handle stress more effectively, along with tighter quality control measures to catch contamination earlier in the process. On paper, these changes directly address both the root cause and the engine's weakest points. Still, not everyone is fully convinced the problem is completely behind them. There have been scattered reports from owners and independent mechanics suggesting similar bottom-end failures in some 2025 and early 2026 models. These cases are not widespread, but they've sparked ongoing debate. Is this still residual contamination, or is there a deeper sensitivity in the engine design? Modern turbocharged engines operate under higher pressures and temperatures than older, naturally aspirated V8s. That means tighter tolerances and less margin for error. Even minor contamination can have outsized consequences in such systems. Another challenge has been the scale of the solution itself. Replacing such a massive number of engines is a logistical undertaking of enormous complexity. Some owners have faced long wait times, limited access to loaner vehicles, and delays caused by parts shortages. This is where Toyota's reputation is being tested most, not just in engineering, but in customer experience. Zooming out, this situation reflects a broader shift in the truck industry. Automakers, including Toyota, are moving away from traditional V8 engines toward turbocharged V6, hybrids, and more advanced systems. These changes are driven by efficiency standards and emissions regulations, but they also introduce new vulnerabilities. Older engines were often more forgiving. Modern engines demand near-perfect manufacturing precision. The tolerance for even the smallest defect has shrunk dramatically. So has Toyota truly fixed the problem? The most honest answer is largely yes, but it's still being proven over time. Toyota has acknowledged the issue, identified a clear cause, committed to full engine replacements, and updated its production processes. Those are all strong, decisive steps. However, questions remain about whether debris was the only factor, how updated engines will perform long-term, and whether newer reports signal lingering concerns. For owners, the best approach right now is to stay proactive. Check whether your vehicle is part of the recall. Pay attention to warning signs like knocking sounds, power loss, or rough engine behavior. And if your truck qualifies for an engine replacement, it's worth scheduling it, even if the wait is inconvenient. Ultimately, this situation is bigger than a single model or recall. It represents a turning point in how modern trucks are built and the new challenges that come with increasing complexity. How Toyota handles this over the long term will likely shape its reputation for years to come. Because in the end, especially in the truck world, one thing matters most: the confidence that your engine will keep going when you need it most.